Hi everybody. Okay. Thanks for joining our talk today. Today we are going to introduce some new features of Kubeflow, including multi-tenancy and self-served workspace and accelerator specs to smartly choose pods to run your workload. So what we are going to walk through today. So today's feature is mostly around end users. So we will enable end users with multi-tenant self-served workspaces for developers and data scientists. Imagine that you will have a dynamically created and managed workspace for each of your team members. And we try to not settle the end user with Kubernetes details. So Kubernetes is good with a ton of benefits, but apparently it has some disadvantage, like it gets too much like Kubernetes specific domain knowledges, which is kind of sometimes become a burden for the end users. We try to hide those details as much as possible, and we try to deploy jobs to the right CPU or GPU nodes. Imagine you have very large clusters. You have nodes with different specs. Some has like memory optimized, some has computation optimized, some has like GPUs. Will help load shift the loads depends on the job types you specified. And finally, we have like customized overlay, which is like a pre-configured specs for the job types. Let's say I define a job template for this type of jobs. For this type job template, I want like high GPU resources, and that template can be used to simplify user experience. So briefly introduce like Kubeflow. Kubeflow is a platform for ML workloads, ML products on Kubernetes. So everything in Kubeflow is Kubernetes native. So our top priority is to resolve the end-to-end problem from the time that we upload data to the workflow until all the way in that we serve the model API on a public or private endpoint. So we try to reduce the effort on every step of this project. So why Kubernetes? KubeCon and everybody coming from Kubernetes, have right users. Finally, some benefit about Kubeflow. So the Kubeflow is a pure open source project. So all the technical details, all the demos we are going to do today is available on our like GitHub. So you can try it out yourself offline after the talk, and join the contribution if you want. Like we have like 200 plus members actually. And we have 20 plus organizations like joining the efforts. And currently it has like cloud providers, Google Cloud, the GKE engine, and AWS and Azure. And it can also be deployed to existing Kubernetes clusters. So some brief introduction about the available applications today. So for experimentation, we have Jupyters and notebook spawners. Like you can spawn dynamic notebooks on demand to do some quick training. And for distributed training, there are TensorFlow and PyTorch CRDs. You can just submit a CR to create distributed training jobs together with the hardware resources you wish to have for this training job. And we get a category for hyperparameter training. And if you want to build a DAG, for example, I want to build a DAG all the way from data labeling to training to serving and to monitoring the feedbacks and re-entering the loop, I can build pipelines to build a ML workloads DAG. And we get metadata to record the metadata of every steps of the pipeline. And for feature store, they are fixed, available. now let's just describe a bit about multi-tenancies for like end users. What's the like desired experience we want? So all the users will operate on the same Kubernetes clusters, while each users only have access to their own workspace by default. So they can only access the services hosted in their own workspaces. And the workspaces are logically isolated by all means. Each user access is gated across methods. So take a closer look. Imagine we have two users, one James, one Sarah, and they are, imagine like say they are accessing services through the shared ingress, and behind it, James has its own workspace, and Sarah has its own workspace, and all the services in James' workspace only available for James, and all the services inside Sarah's workspace only accessible for Sarah. And we can also set up a workspace for a teammate, a team like this workspace. Those kind of services are only available for this team. That's the desired state we want to achieve. We will go through a demo later today to illustrate how it works. So some common challenges. I know like Kubernetes multi-tenancy has become like a hot topic, and some shared common challenges include, like say, first thing first, like we need to define a clear definition for the user workspace, like what is the user workspace and how we want to build the access control around it. The second challenge is the Kubernetes in-cluster network is transparent. By that I mean if you create a Kubernetes service and you deploy it within the cluster, so any pod in the cluster can access this service by default. And the third is the access control around the traffic through the shared ingress. Imagine we have a Kubernetes cluster. Usually, when we expose it to through an ingress, we will usually the general practice is we use one ingress for one clusters. So, but now we have like a dynamic number of users, and they will share the same ingress. How are we gonna build access control around the shared ingress? That's an interesting problem to solve. And a nice thing to have is about the workspace access sharing and revoke. It's like, imagine I'm cooperating with my teammates. I want to invite my teammates to access my services. It will be really nice that if I can do it like smoothly and easy. And finally, all policies, roles, and bindings involved for all about steps need to be like inconsistent. They should all agree with each other, like who have access to what resource or not. So now it comes to our current choices. So inside Kubeflow we have a new CR called Profiles to manage the access control and policies. So we define a user workspace as a namespace and build access control around it. The access control to namespace is controlled through a Kubernetes RBAC policy. It's like all the standard ways to control it. I believe it's the choice, the same choice for most projects. And the second, we leverage Istio to control the in-cluster traffic. So Istio has a Istio RBAC to control the in-cluster traffic and manage through Istio policies. And the third, we leverage identity-aware proxy. So this identity-aware proxy is different across like cloud providers. Different cloud providers have their own access identity proxies. Like depending on your public cloud provider, or if you are working on-prem, you might need to set up your own identity proxy. And Istio policy on the back to consume the identity in the request and apply the RBAC check against the existing Istio policies. So we also enable the workspace access sharing and self-service through the Kubeflow UIs. So we'll cover this tool in the demo later. And finally, the Kubeflow Profile CR, together with its controllers, responsible for the consistency of different policies involved in the process. So one nice thing is we also offer plugin interface, which you can define your own custom logics to control the resources within your organization that doesn't host it inside the Kubernetes clusters. By that I mean, like imagine we have something like a storage or cloud policies that we don't want to. We cannot host inside a Kubernetes cluster, but we want to update it per when we add or remove users. So you can implement your own logic to say add a disk or remove disk, or add a user to a database or remove it from database, depending on your use cases. We are going through one examples later. So a quick diagram explaining how it works. So imagine there are two ways user can access the services within Kubernetes clusters. So one way is definitely the most common, maybe through browsers, and another is through kubectl. They are going through different endpoints. So by that I mean, like, for example, when you make a kubectl request, the request actually goes direct to the Kubernetes master proxy IP address. And when you are making a request through browsers, that request is going through the shared ingress directly. They are actually different paths. If you so the request going through the browsers, the access was controlled by EC RBAC, while the request going through the Kubernetes proxy directly, that one is controlled by the Kubernetes RBAC. These two have similar names, but they are different things, and they are all like controlled at the same time through the profile CRs. And users namespace, the user workspace definition as of today is like a namespace, right? And all the requests, if they are allowed, they'll go to the end user's own workspace and the services inside it. So
yeah, so the Kubeflow profile, as we stated in the beginning, was intentionally meant to be simple as part of a self-serve paradigm. So the user is able to just specify the name, which becomes the workspace name, or the namespace name, and then they just specify their name as the owner. And so this facilitates data scientists creating more than one type of workspace where they can run whatever they want, training or inference. And so there are two ways to create a profile. One is through the YAML file and invoking kubectl, and the other is through the UI. If you look at the left, you'll see that the profile is slightly more complicated in that a plugins field was added. This is added as after the profile controller gets the profile, and it adds, in this case, the user's identity, which maps to a GCP service account. In this case, we have a pathway to allow GCP cloud resources to become available in the workspace transparently to the user by adding to the profile. And obviously, you wouldn't want to allow this plugin to happen by the Kubeflow user. You'd want it to happen within the back-end side so that it can be controlled. So again, you have a choice of how you get started, how you create your workspace. You can either use a YAML or you can use the UI. And once the profile has been created, you have an option of inviting others. Typically within a namespace, you probably want some peers with perhaps slightly less permissions or a slightly weaker RBAC model to either observe or to partake in the work you're doing, whether it's training or inference. And so as the owner of a profile, you can bring up the UI. There's also equivalent kubectl commands. And you choose a contributor that is your peer that you want to invite into your workspace. And then after you add them, they show up within the UI as a member. And this is not unlike a number of other UIs where you can have contributors rather easily. Switching gears slightly, now that you have a workspace set up and you're a data scientist, the next question is, how do you get your training or your inference job deployed to the correct node? So this is the second feature we are integrating into Kubeflow, and that is as training and inference become more and more common, as hardware chips become more and more varied with multi-node distributed capacities, how do you best deploy your job to the right place? And so we're enabling this by basically offloading this task from the data scientist. If the data scientist chooses to insert a string that indicates, for example, they want their job executed on a GPU, we do not prevent that from happening. The idea here is that we provide some extensions that would allow vendors or DevOps to provide that sort of information. And so, as you saw 2 slides ago, the KubeProfile had a plugin that accounted for allotting cloud provider resources to the user. This section will also be added on the back end, not exposed to the user. The obvious issue here is if you were to allow the user to do it, it violates 2 things. One is now we've exposed the complexity of Kubernetes to the end user, and 2, they could effectively take over the cluster and a lot, all the GPUs or TPUs out there. So, so the idea is that this would be inserted, and it could be inserted by an admission controller or by GitOps. And so this is an extension mechanism that we don't particularly have a particular say on, but we leave it open for the appropriate tooling or the appropriate workflows, so that, for example, you may have, in the case of Rancher, for example, that pre-allocates namespaces for users, you might have 4 or 5 namespaces. One might specialize in BERT, the other might specialize in Inception. And so you would want those namespaces optimized to be deployed on the right type of nodes. And this could be set up by DevOps, for example. You may hook it up to GitOps so that it ends up being a PR if someone then has a particular request, and then it could be approved and they're off and running. So the idea is you could either slice this up at a namespace level by model, or you could slice it up by data scientists and what they're allocated. We're agnostic as to how you would go about specifying that workflow, but this is a feature that we're going to push forward and hopefully get some input from the community. So as part of the demo today, after Kunming shows you the UI and the profile piece, I thought we would run a Tekton pipeline. And the pipeline is just going to run a model. And the pipeline will specify, actually for this demo, we don't have a, it was originally in the original demo, it was supposed to bind to a CPU of Cascade Lake, but we don't have that in our cluster today. So it's, we're not showing a CPU binding, but for example, in the CPU type, it's parameterized so that you could specify a particular Xeon class. So for example, if you're running BERT and you need, maybe you need, because of the large input size, a high-end Xeon processor like Cascade Lake or Skylake, you can make sure that when the job is deployed, it finds that pair, a Cascade Lake and a GPU, or a Skylake and a TPU, for example. The other thing that this will show in terms of the overlays is the task patch. And the task patch, if you see here, is asking for a NVIDIA. So it wants to run on a GPU. And here, the task is, as you can see, has no information about NVIDIA in it, but via the overlay, the NVIDIA string under limits is inserted. And so what you have then is where these parameters are provided, as we do in other use cases in Kubeflow, via a config file. So the config file has all the parameters you need in order for you to run that particular component successfully. In this case, you have on the left-hand side the accelerator and the count you want, and on the right-hand side the CPU and the type of processor you want. And I'll hand it over to Kunming now.
So now it's demo time. So let's get started. So today we are going to use two accounts. One is kubernetes.com. This one has admin permissions for existing cluster. Another is at kubeflow.org. This one has guest permissions or normal users for the cluster. So let's just fetch the credential again. Now on CLI side, I'm logging as the guest account, and let's take a look at the Kubeflow UI for both users. So here's a Kubeflow UI of a fresh deployed clusters. If you deploy Kubeflow on any like platform, follow the instructions in our document, you should be like get the same exact same clusters. So here is all the contributors and identities. So as an admin, I can see all the namespaces available inside the cluster. I have a Kubeflow premium is owned by this account. I have Kam's namespace owned by Kam. So, and if I want to start a notebook, say, and start a notebook in my own namespace, I can connect to my own notebook and just run some random things. Anything can be run. Now I just print out some random messages. And now let's switch identity and use a guest account. So here's a guest account, and for the same UI. So the first time, for example, the first time a user logs into the Kubeflow clusters, if the cluster detects that this user doesn't own any namespace, it will walk you through a setup and to set up your own namespace. This one I give it a name called guest. And finish. So everything should happen really fast. So after I set up my own namespace, my guest account should have access to the guest namespace. And on the admin side, you should notice that a new namespace is being created. See, here's the new namespace we just created, owned by this guest account. And the guest can now, for example, create his own, let's see, guest one, my own notebook, a service, in my own namespace. So let's take a look at the CLI. So by default, if I'm, as a guest account, if I want to fetch all the namespaces, I will be denied because I don't have access to all the namespaces. But if I only want to get resources, let's say within my own namespace, it's doable. Let's see. Yeah. So this is the notebook I just created. It's been like initialized, and I can also check all other things like service account. Typo? No. Let's say I try to get a service account from admin namespace. I will be denied because I don't have permissions to list resources in the admin's namespace. So now for guest, I have my own notebook setup. And now let's try the access sharing. So imagine like admin decide like for some reason I want to share my workspace with my guest account. Like say I want to invite my guest to edit my notebook, and then it's pretty easy. I just add a contributor to my namespace. I just hit enter. So like notice here. So if I refresh the page, it will be like auto edit on the UI. So and again back to the guest side. So now I only have access to the guest namespace, but if we refresh again, then I have access to the owner's namespace as well, and I can access to the. It will take a while. Let's see. It should take up to 30 seconds to sync. So let's try to get the pod within the guest within the admin namespace again. Okay, so now on the CLI side, it's synced up. I can have access to the resources in admin namespace now. Let's try the UI side. Okay. Okay, now I have access on both sides. I have access to the admin's namespace on both browser side and CLI side. And finally, let's try out the remove access. And let's see, admin decide that the cooperation is done. I want to revoke permissions from my guest account. I just click, and it gets removed. It should happen after. It should be synced within 10 seconds, but we can try now. Now the permission gets removed. I don't have access anymore. And on the browser side, usually it takes up to, oh, it's not, this one is still the admin Windows. Let's see, this is the guest window. And it's get auto removed. Now I only have access to my own namespace now. So the above demo is all about the access sharing and the revoke for the multi-tenancy experience for both CLIs and browser controls. So next we will demo the accelerator plugins.
So we're sort of short on time on that.
I think it's about time, so I'm just wondering if any question from our audience. Any questions?
Thank you. Is there a way for normal contributors to share namespaces between them? Because I noticed that you had to access through the management tab. So.
Yes. Let's do it now. So this one is the guest account, right? I'm logging in as guest account. Now I want to add, for example, I want to invite an admin account to my namespace. I can do the same thing. It's just I can just type in the account here, and the admin account now is invited. If you refresh from here, you can see the admin account is get added to the guest's namespace. So for example, every account is the owner of his own namespace. By that I mean the namespace owner can feel free to add and remove as many users as they want.
Did you want there's a kubectl equivalent to?
Yeah, if you want to use the kubectl, you can do it as well.
Okay, any other questions? Okay.
Hello? Yeah, so for the resources for a profile, which is CPU and GPU resources, which you showed, I think it's only possible with kubectl right now. And is there a way where an admin could set defaults and change the default per profile rather than
Yes. So like as our demo mentioned earlier, we define like a pod spec or profile spec for different kind of loads. For example, for example, this team does a lot of like ML training, and that team do a lot of like servings, like production servings. So the training team might want a lot of GPUs, and the serving team might want high memories. So we define different profile template for the different profiles. So the training team can use the profile templates with high GPUs. So all the pods spawned in their namespace will have like GPUs attached to the pod. While on the serving team, they will get high memories. It's like customizable, for example, across teams or across users, depending on the type of workload you want to run.
So that's an area that doesn't get to be specified by the user. It's added by the controller. Otherwise, it defeats the purpose. You know, you could ask for 5 or 10 GPUs and block everyone out. So, and then it's up to either like a GitOps paradigm or a DevOps paradigm where the flows would be inserting that, and you could say, well, this namespace is specified for a training for that requires Cascade Lake and a TPU 100, I think.
Yeah, we are running out of time today for the demo, but you can try it out because it's all open source. So if you want to try different hardware specs, you can like follow our document to deploy the same clusters and try the feature out. Yeah.
Okay, I think we are running out of time. If we have any further questions, I think you can continue discussion across the hallway, and remember to submit your feedback in scat.com. Thanks for everyone joining the meeting.